Look at this simple harmonic motion. We're going to write down the amplitude, the center, and the extremes. Let's start. Center is 0 because there's nothing added. C is 3 sine t. Period is 2 pi divided by 1, which is just 2 pi. And then the amplitude is 3, the number in front of sine, 3. So the extreme will be 0 plus 3 or 0 minus 3. So the extremes are 3 and negative 3. Okay, write it down. Once you do that, find the equation for velocity and acceleration. And then we're going to use it to draw the graph and answer various questions about this. Alright, so velocity will be 3 cos t, and then acceleration will be negative 3 sine t. Okay, write down the equation for velocity and acceleration. Yep. And then find acceleration as a multiple of the displacement. So acceleration equal to negative x. Okay, so that's x. Alright, after we do this, we're going to sketch all 3 graphs on the number plane below. So sketch all of this. Oops. Okay, so sketch all of this. So you got x, t, and x double dot. So starting with x, 3 sine t. 3 sine t will be like this. 0, pi, 2 pi, 3 pi on 2, on 2. 3, negative 3. Yep. Oh yeah, sorry, I forgot to change 2 pi. Yeah. Alright. 2 pi, and then do the same thing for the other bit. So this is x against time, and then we'll get v against time, which is the cos graph. 3, negative 3. Pi, pi on 2. 2 pi, 3 pi on 2. Do the cos graph. So that's v against time. And then draw the acceleration. Okay. Alright. Alright, do them all. Next one. Do the sine as well, which is 2 pi, which is 3 and negative 3. So it's go upside down. 0, pi on 2, pi, 3 pi on 2, 2 pi. And then you go this. Okay. Okay, draw all 3 graphs, then we're going to answer some question about it. Alright, draw all of them. Thank you. Okay. Now we're going to answer some question about velocity. Now, when it is on the upper extreme, that occurs at this time and this time. What's the velocity? No. At the upper extreme. So that's the upper extreme. Upper. What's the velocity? Velocity is 0. Good. So put 0. How about negative extreme? or the lower extreme? It's 0 as well. 0. So basically, in the simple harmonic motion, it stops at the extreme, isn't it? Just imagine the spring. And then what happened at the center? That's the center. The velocity is, what's the velocity at the center? It could be 3 or -3, isn't it? So 3 or -3. So it's at maximum speed. The speed is maximum. But the velocity could be max or minimum. Okay? So at the center of the motion, the speed is maximum, but at the extreme, it's 0. Let's look at the acceleration. How about the acceleration at the center? Let's make it smaller. At the center, the acceleration is, what's the acceleration at the center? It is at 0. So no acceleration at the center of the motion. And what happened at the upper extreme? What's the acceleration? -3. What's the acceleration at the lower extreme? It's at the maximum. So we can say lower extreme, the acceleration is max, and then in the upper extreme, it's min. And this is due to the fact that the acceleration is equal to the -x. So if x is 3, at the upper extreme, the acceleration is -3. But if the lowest, but when you reach the lower extreme, the acceleration will be maximum 3. So we're going to look at a GeoGebra animation on the spring to have a better understanding of this. So once you finish completing, we'll look at the screen. Okay, so that's the spring again. So if we play this, it moves up and down. Now we can graph the x against time. We'll get the sign, get the graph. Now let's look at it again, but we're going to look at the velocity. So if I play the velocity, so basically as you reach the end point, there's 0 velocity, stops. And then as you reach the middle, it's the maximum. And then if I do that again, and then it stops when it gets to the end points, and then it stops when it's at the end point. Okay? And then what you do is, what if it's acceleration at the end point, the acceleration is maximum, but when it gets to the middle, it's 0. So if I do this maybe a bit slower, so we'll go again. Okay, so if you look at it, at the center of the motion the acceleration is 0 because there's no stretch. But as it gets stretched, the acceleration is in the opposite direction to the displacement. So as you get to the end, there's acceleration here, 0, negative, and then positive, and then positive. Okay, so that's what we see from the spring. Okay, so at the end point, the acceleration is maximum or minimum in the opposite direction to the displacement, but the velocity is 0. It stops at the end. And at the center, the velocity has maximum speed, but the acceleration is 0. So note this table, remember this table, because this table will be important later on. Okay, so we're now going to focus today on how to come up with an equation given a problem. So we're going to go to the next page. All right, so we'll go to the spring example again. So at the extreme position, x is, so in this case, x is 3. Let's say x is, the one before is x is extreme position. Okay, so this is x is -3. This is x is +3. This is x is 0. So at the extreme, the velocity is 0. It stops at the end point. Like that. And then the acceleration at the extreme, it's in the opposite direction, 3. This is maximum. Okay, because when you stretch it, you want to push it back. And then when you compress it, you want to push it forward. So you get negative. So that's minimum. But when it is not stretched, the acceleration is 0. Okay? Because when it's not stretched, it doesn't push you forward or push it upward. But the velocity at this point will be max. The speed will be maximum. Speed equal to max. Or max speed. Max speed. Okay? Max speed. So the velocity is could be max or min, depending on which direction it's moving. So it could be moving down at this point or could be moving up at that point. But at both of these cases, the speed is maximum. Alright, so now we're going to look at different ways to model the graph, the simple harmonic motion. So there are different equations you could use to model equations. So depending on the initial positions. So it all depends on the initial position. So if your initial position starts from the positive extreme, you will use this graph, A cos nt plus C. But if you start from the negative extreme, you have an extra negative outside. So it looks like this. So that's A, that will be negative. So if you start from positive A, positive extreme, you use A cos nt plus C. But if you start from the negative extreme, you do negative A cos nt plus C. But what if you start from the center, you use sine? So if you start from the center, you use sine. But if you start with center with a negative velocity, it goes to the other way, you use negative sine. Okay? And then what if you start from other positions, then it could look like this. So in that case, you have to have an extra alpha there. Alpha. Or you could add A cos A sine nt, B sine nt. Okay, so we look at example of this. If it doesn't start from the center or the extreme, use these ones. So any of these will work. Alright, so after we do this, we'll do an example. So we're going to model the height of the tire using simple harmonic motion. Okay, so we'll go to the next page. Alright, so we'll look at this problem. Okay, so tides can be modeled by simple harmonic motion. On a certain day, the depth of water in a harbor at low tide is 3:30 a.m. is 5 meters. At the following high tide is 9:45 a.m. The depth is 15 meters. So we'll note the time and the height of the tide. Assuming the rise and fall of surface water is simple harmonic, find between what times during the morning may the ship safely enter the harbor if a minimum depth of 12.5 meters of water is required. Okay, so basically, when t equal to 0, x equal to 5. And then when t equal to something, x equal to 15. So how many hours is that? 3:30 a.m. to 9:45. You subtract, that will be 6:15, right? So 6.25 hours. So what you could do is you can start looking at the graph. So at 0, low tide is, the depth of water is 5 at low tide. And after 6.25 hours, which is 6.25, that's in t in hours, and x in meters, it becomes 15. Like that. So we see that it starts from the lower extreme, isn't it? Right, starts from the lower extreme. So in that case, the equation for the graph must be negative a cos, because start from the lower extreme, nt plus c, where c is the center of the motion. So to work out the equation, you just have to work out 3 things: the amplitude, the period, and the center. Let's work out the center, then we can work out the amplitude. The middle is this bit, that's your c. How do I work out c? You just have to do the average. C equal to 15 plus 5 divided by 2. So the center is at 10. 10. And once you get the center, then you can work out the amplitude. The amplitude is 5. A equal to 5. So the hard part maybe for working out the period, which is related to n. So how do I work out the period? Now, the period will be from 0 to this point, going back to the lower extreme again. That's one period. So what you could do is you can double this time. So one period must be double 6.25, which is 12.5 hours. That's your period. And then you can find n, because period equals to 2 pi over n. And then period is 12.5, so you can solve for n. What's n equal to? N will be 2 pi over 12.5. And then you just use your calculator to simplify. So you can do it on a calculator. So you go 2 divided by 12.5 equals to, you not use decimal, fraction 4 and 25. So 4 pi over 25. Like that. That's n. So we've got everything. We've got n, a, and c. So therefore the equation of the graph is, the equation of the graph is -5 cos, and then you get cos 4 pi over 25t plus 10. That's the equation of the depth of water. Okay? Alright. I'll just show you the full page. And then we can use it to answer the question. Okay, so we want to find out when could it enter the harbor if a minimum depth of 12.5 meters of water is required. So you have to find at what time would it be 12.5 meters. So let's use this. So that's 12.5. Let's try again. 12.5. So 12.5. So you go like this. So it crosses at these 2 points. So you have to find the time. Okay, what time would it be 12.5 meters? So we solve a trigonometric equation. So you write 12.5 equals to -5 cos 4 pi over 25t plus 10. Subtract both sides by 10, you get 2.5. And then divide both sides by -5, so you get -half. So hopefully you remember how to solve a trigonometric equation. So therefore, it's in the second and third quadrant with the related angle, shift cos +half, which is 60 degrees, pi over 3. Pi over 3, -3, +3. Okay, good. So now you can write down x equals to, or 4 pi over 25t equals to pi minus pi over 3, or pi plus pi over 3. As you can see from the graph, there are two solutions. It crosses twice, cross here and there, so we're going to work out the time. So therefore, continuing on, you get 2 pi over 3 or 4 pi over 3. Like that. And then you have to work out the time, so you have to multiply by the reciprocal of this, which is equal to 2 pi over 3 multiplied by 25 over 4 pi. And what's the other bit? Okay, and then you go 4 pi over 3 times by 25 over 4 pi. And then you just use your calculator to work it out, which is equal to, the pi get cancelled, you get 2, so you get equal to 25 over 6. The other one you get 25 over 3. Which you can convert to hours and minutes. So you go 25/6, and then you press this button, 4 hours and 10 minutes, 4 hour and 10 minutes. The other one, 25/3, and then press that, 8 hours and 20 minutes, 8 hours and 20. That. So these are the two times when you can enter the harbor. And then we'll go back to the graph, 4 hours, and so this is 4 hours, 8 hours and 20 minutes, and this 4 hours and 10 minutes. Okay, so after this, we should work out the actual time, because the actual time is not 4 hours and 10 minutes, so the time will be, you have to add that to 3:30. So 3:30 a.m. plus 4 hours and 10 minutes, that will be 7:40 a.m. Okay, and the other one will be 3:30 plus 8 hours and 20 minutes, that will be 11:50 a.m. Right? So we got these two times, this one and this one, which you can label here. So this is, let's go back here, pen. Alright, so this is 3:30 a.m. and then at this time that's 7:40 a.m. and this is 11:50 a.m. 11:50 a.m. So to answer the question, what you need to do is, when would it be able to enter the harbor? You must have a minimum depth of 12.5 meters. So any time between these two, you can enter the harbor. You will have enough depth, so between these two times. So you will say, therefore, you can enter the harbor. You can enter the harbor. Can enter harbor between 7:40 a.m. and 11:50 a.m. Alright, done. Any questions? So write down the working out. So the hard part is to work out the equation, which comes from the center, and you start from the lower extreme, so it's cos, negative cos. And then you work out the amplitude, the center, and the period. Once you get the equation, you can use it to find the time when it's 12.5 meters. And you have to solve the trigonometry equations. Once you do that, make sure you convert the time in hours and minutes, add that to the initial time of 3:30 a.m. Then you can work out the two times. Alright, once you do this, we can do another question. Example 7. And then there's a couple more modeling. Okay, all done. Alright, so next page. Alright, have a look at this example. Think about what to do. An equation of a motion is given by particle moving in a straight line, given by the equation x double dot equal negative 16x. So when you see that, the first thing you can write down is n. N must be 4, right? That will be useful to find the period. So I could work out the period after knowing this. Then we'll have to find the amplitude. You say when x is 0, v equal to 4 when t is 0. So at the beginning, it's at the origin, which is the center, isn't it? The center is at 0 from here, because there's nothing here. So center is at 0 because if you go back to the original equation, C is the center. And in this case, because there's no numbers, therefore the center is at 0. So we know the center is at 0. It starts from the center. So motion start from center. So start from center because it starts from 0. Therefore, and with positive velocity, so therefore your equation will be x equal to a sine, because start from the center, use sine, nt plus c. And in this case, c is 0. C equal to 0. The centers of the motion is 0. And then we can work out n is 4, that's 4. And you have to work out the amplitude. So that's what we have to figure out. Okay, so now we write down x equal to a sine 4t. That's the equation. You have to work out a. Now to work out a, we know the velocity is 4 when t is 0. So we have to differentiate. So when t is 0, v is 4. So we differentiate, we get v equal to 4a cos 4t. Right? And then we substitute when t equal to 0, v equal to 4. So we get 4 equal to 4a cos 0. What's cos 0? 1. So that means 4a equal to 4, a equal to 1. So we've got the amplitude. So now we've got the formula x equal to sine 4t. That's the formula. And we can write down the period equals to 2 pi over n, which is pi on 2. And then the amplitude is equal to 1. And the question's done. State the, and then we have to find the displacement at any time. That's the equation. We've done that. State the period and the amplitude. All done. Good. So now we know how to model equations. So we'll look at the clue in the question, decide on which equation to use. We'll do the next one. So the next one, the motion will not start from the extreme nor the center. Let's see how that works. So let's look at the next page. Okay, so have a read. Say again. Oh, sure. Amplitude 1, because A is 1. See, I solve for 1. V is 0, 4. So A is the amplitude. Oh, because the question says find the period. So 2 pi over n. So if you look at the question, find the period. Yeah. Yeah, go good? Okay. All right, let's move on to the next question. Thank you. All right, example 8. So a particle moves on a straight line, so the acceleration is given by that. So when you see this, the first thing you can say is n squared equal to 4, n equal to 2. And the center is at 0. So you can say two things. You can work out the center and the period based on this acceleration in terms of x. All right, now, so we can work out the period. We'll still have to work out the amplitude and the displacement function. And we're given this information. Okay, let's write it down. So at the beginning, it starts with x equal to 3. Now, can x equal to 3 be the extreme? Why or why not? How do we know? What happened at the extreme? It must be, so at the extreme, yes, v must be 0, as we see from the spring, right? But since it's not 0, x equal to 3 cannot be the extreme. So it doesn't start from the extreme, nor does it start from the center, 0. So therefore, if it doesn't, so therefore, motion does not start from the extreme, does not start from extreme, nor from the center, which means that I have to use maybe a sine nt, but we have to add an alpha there because it doesn't start from the center. It doesn't start from the extreme. So you have an extra alpha you have to work out plus c. So that's the formula you use. But the good news is we've already know what c is. C equal to 0 over here. We already know that n equal to 2. We just need to find out the amplitude and the alpha. Okay, let's update our formula. So x equals to a sine 2t plus alpha. That's the equation. I have to work out the alpha and the a. Let's do that. So how do we do that? So we use the information. When t equal to 0, x equal to 3, v equal to negative 6 root 3. So we need to substitute that into the x and the v. Let's write down what v is. V equals to 2a cos 2t plus alpha. So I could substitute this information in to work out the alpha and the a. So let's substitute the first part. When t is 0, x equal to 3. 3 equal to a sine 0 plus alpha. A sine alpha. Right? Equation 1. We're going to use simultaneous equation. So when t is 0, v equal to negative 6 root 3. So you get 2a cos alpha. And then divide both sides by 2. We get this. Equation 2. So now we solve simultaneously. Now how do we solve a and alpha? Now to work out a, what you do is we're going to square both equations. You probably have seen that technique before. We're going to square 1, square 2. So why do we square? We do 3 square equal to 3 square plus negative 3 root 3 square equal to a sine alpha square plus a cos alpha square. Like that. And why do we do this? Because when you square the trig function, we know sine square plus cos square equals to 1. So that gets eliminated. So a square equals to 9 plus 27, so 36. So the amplitude is 6. Alright, the next thing we do is we're going to find alpha, so we're going to divide 1 by 2. So we end up getting 3 over negative 3 root 3 equal to a sine alpha over a cos alpha. Then the a gets cancelled, and then we end up getting tan alpha equals to negative 1 on root 3. Right? Okay, so what you do is you just use your calculator. So just do shift tan negative 1 over root 3. So in this case, just write down the negative angle. So negative 30, so negative pi on 3. Okay? Instead of writing the angle in the second quadrant, you just write the angle negative pi on 3. So now we write down the answer. So therefore, x equals to 6 sine 2t minus pi on 3. That's the equation of the motion. And once you get the equation for displacement at time t, you can work out the period and the amplitude. So therefore, amplitude equal to 6, period equal to 2 pi over 2, which is pi. And that's done. I'll show it for a couple more minutes. Alright, pi on 3. Because if you do shift tan, it's, oh, actually you're right, pi on 6. Yes, 30 degrees. So it should be pi on 6, you're right. Oh yeah. Okay, I got mixed up with 30 and pi on 6. Okay, pi on 6. Alright. Very good, okay. Alright, all done? Now before we do the last one, let me show you a different way of doing this. How much time? We spent 34 minutes already. Okay, alright. Maybe I'll just add a page. Okay, I'll show you a different way of doing the same question. Method 2. Hopefully you still have space. You should learn method 2 as well. It's important. Now, how does method 2 work? Remember, when the motion starts from the extreme, we use, what do we use? A cos nt, right? If we start from the center, what do we use? A sine nt. So what if it's neither center or extreme? A sensible way is to have both of them. A sine nt, but use a different letter, B cos nt. Get the idea? Of course, if the center's at the, if there's a center, you just got plus C. But in this case, C is 0. So we know it's going to be this. So this is slightly different from the other one. Remember, the other one we use equal to A sine nt plus alpha. And they're equivalent. Remember the auxiliary angle formula. So this can be expressed in this form. And does that make the question easier to solve? In some sense, it does make it easier. Let's see why it makes it easier. Now, the first thing we note that n is still the same. N is still 2, right? So we can write down x equal to A sine 2t plus B cos 2t. Right? So the hard part is to work out what A and B is. Okay, so how do I work out A and B? So when t is 0, x equal to 3, v equal to negative 6 root 3. Now, let's substitute 0 in here. What happens if we substitute 0? We get 3 equal to A sine 0 plus B cos 0. But what happened to sine 0? It's 0, right? So you end up getting B times 1. You work out B straight away. You don't have to solve simultaneous equation anymore. You get 3. So x equal to A sine 2t plus 3 cos 2t. And then you differentiate to find v. Now v will be equal to 2a cos 2t minus 6 sine 2t. And when you put t equal to 0, v equal to negative 6 root 3. So you get 2a cos 0 minus 6 sine 0. What happened to sine 0? Now this time this is gone. You can find a now. So you get 2a equal to negative 6 root 3. So a is negative 3 root 3. So now we've got the formula. Therefore, x equals to negative 3 root 3a sine 2t. And then what was b? B is 3. So 3 cos 2t. Can you see I could find the equation without solving simultaneous equation? So that's the advantage of using this method. But what's the disadvantage? You aren't able to get the amplitude. But even getting amplitude is not hard, because now you know this can be converted in the form of r sine 2t minus alpha. So what's r? Square root of negative root 3 square plus 3 square, which is your amplitude, 6 amplitude. So if you like, you can use this way to find the equation. Okay? All right, any question? We're going to move on to, maybe we'll skip that because I think that's okay. All right. Actually, we'll do a summary, and then that's it. We'll skip that example, and we'll do a summary of everything. All right, let's do a summary. Hopefully all finish. Next, next, next. Okay, all right. Let's do this question. Summary of simple harmonic motion. So for time equation, that's only time equation. We still got another bit to go for simple harmonic. Now for A is the amplitude. So write amplitude. Amplitude. And C is the center. Period is 2 pi over n. So we can represent simple harmonic motions with A sine nt plus C or A cos nt plus C. Or other equation you could use is A sine nt plus B cos nt, or plus C, or you can use this bit, x equal to A sine nt plus alpha, or A cos nt plus alpha. Okay, so these ones where the motion does not start from the extreme nor the center. This one, the motion starts from the center. Start center. This one start from the extreme. This is neither. Okay. And then to prove something is simple harmonic, remember to do this. X double dot equals to negative n squared x minus c. Okay. Now, actually, I forgot. There's two more we've done. Remember, this is also simple harmonics, like 3 cos squared 2t. So that can be converted to this form. So see the older example, and then there's other example of x. Oh, which I wrote it here. Yeah. So you have to use double angle formula. Use double angle formula. Use double angle formula to convert, and we have discussed that in example. What example is that? Example 4. Okay, so see example 4. We did that. Right. And after we do this, now we did modeling problem today. So if you start from the positive extreme, use a cos nt plus c. Negative extreme, we do negative a cos nt plus c. If you start from the center, we use sine a sine t plus c. If you start from the negative velocity, negative a sine nt with negative velocity. Okay. And what if it doesn't start from neither center if it doesn't start from the center or the extreme, you use x equal to a sine nt plus alpha plus c, or x equal to a cos nt plus alpha plus c. Or the third way is the one we I just showed you today, a cos a sine nt plus b cos nt plus c. So there are 3 different ways you can use to model solution. I usually prefer to use sine rather than cos, because when you differentiate sine, it's positive. That's why I prefer sine. What else? I think that's all. And then we can see there are similarity with the other course, with the exponential decay and growth. Exponential, so this is a e to the power kt. Whereas when you see that acceleration in terms of displacement, you get x equal to a sine nt plus nt. And then when there's a e there, that's in extension 1, e plus a e a t. And this one you get x equal to a sine nt plus c. Okay. Of course, there's other ones that you could use. All of this will satisfy, so you could also write x equal to a cos nt. That will also satisfy that. Or you can do x equal to a sine nt plus b cos nt. That will also satisfy this equation. Or you can do x equal to a cos nt plus alpha, and many more. Alright, so that's the summary of this topic, and then tomorrow we'll do something else. Not tomorrow, the day after. Thank you. Alright, start the exercise. So